Good morning, Grade 7s, and welcome back to WorksheetCloud, Grade 7 Natural Sciences. You know the email Grade WorksheetCloud if you have any questions. So today's lesson is energy for life on Earth. So we're going to be looking at solar energy for life on Earth. And for those of you who don't know me, my name is Mrs. Hall, and I look forward to teaching you this lesson today. So, lesson from grade 6. How plants produce food through the process of photosynthesis. Plants light energy from the sun and make food. In this way, the sun's energy is captured and stored so that it can be used later on. And yes, you must all surely remember this diagram from grade 6. Water, carbon dioxide, and energy, as well as nutrients from the soil, provide us with glucose and sugars and oxygen. So, synthesis, the energy from this is used to change the carbon dioxide and water into carbohydrates, for example, cellulose, starch, or glucose. The carbohydrates are stored in fruits, leaves, wood, bark. When we eat the plant, for an apple, our bodies are able to release stored in the carbohydrates. In the same way, animals, for example, use the sun's energy when they eat the grass. Okay, so all coming back to you. So let's take a look at the food chain over here. All plants and animals depend on photosynthesis for their. In previous grades, you learned about energy transfer between producers, for example, grass, consumers, for example, a buck or a lion. You used food chains and food web, how energy is transferred. And you know that plants play a vital role in life on Earth. Plants, without them, life on Earth would not survive. Completely dependent upon the sun for survival and out without its energy to synthesize. Okay, and here we have our basic little food chain. It all starts with solar energy from the sun. The energy is transferred, and remember, the plant has potential energy that is transferred to animals that use it for energy of movement. So, what would happen if the sun's rays from reaching Earth? Can you just imagine, sevens, what would happen? So, imagine a world without the sun. How can this happen? It has happened before in Earth's history. Dinosaurs lived on Earth millions of years ago. They were the dominant terrestrial vertebrates until about 65 million years ago, when there was a massive extinction. There are several theories about what caused this mass extinction. The most supported theory is that a massive asteroid hit Earth. It entered the Earth's atmosphere with a brilliant flash of light and crashed into a shallow sea. So, huge pieces of red hot rock and steam exploded and caused raging fires, which destroyed parts. The asteroid's impact, giant waves called tsunamis, which the coastal lands. Scientists think that the impact could have started a series of volcanic eruptions. And here we have an artist's impression of the asteroid impact 65 million years, which scientists think is the most direct of the dinosaurs' sudden extinction. This is a huge cloud of ash and dust in the atmosphere, blocking these huge clouds of ash, dust, and steam quickly spread all over Earth and blocked warm rays of the sun. Scientists hypothesize that this cold, dark environment lasted for months or even years. Right, scary. There's our asteroid, and there are our dinosaurs running. So much more recently in Earth's history, there was a supervolcanic eruption at the present site of Lake Toba in Indonesia. This occurred about 70,000 years ago when Mount Toba erupted and sent a huge volcanic ash cloud into the atmosphere. The eruption was followed by a 6-year-long volcanic winter as the ash blocked out the sun's rays, and a 1,000-year-long ice age. Following the eruption, Mount Toba collapsed inwards, and today the site can be seen at Lake Toba. And if you look over here, this is a satellite image of Earth's largest caldera, 30 times 100 kilometers, partially filled by Lake Toba, formed during the supervolcanic eruption about 70,000 years ago. And you might ask, what is a caldera? Caldera meaning cooking pot in Latin, large volcanic feature, usually formed by the collapse of land after a volcanic eruption. So let's now pretend that another event occurs in present day, blocking the sun's rays from reaching Earth. What would happen to the people, animals, and plants on Earth?
The all-powerful sun. It brings us light, warmth, and without it, there wouldn't be much life on our planet. But have you ever actually wondered what would happen to life on Earth if the sun suddenly burned out? Let's find out on today's episode of Colossal Question. The sun is a star in the center of our solar system that all the planets orbit around. It's because of the sun that life on Earth exists in the first place. Experts have determined that the Earth's distance from the sun is just the right distance for humans to survive. If Earth was a little closer, we'd all be burnt to a crisp. But if it was a wee bit further away, we would all freeze to death. Or, in other words, almost all living things on Earth rely on the sun for survival. So that leaves us with a pretty big burning question to answer. What would happen if the sun suddenly burned out? Well, for starters, it would take over 8 minutes before we'd even notice here on Earth. That's because the sun is so far away that it takes light over 8 minutes to get from the sun to your eyes. But once those last magical minutes passed, it would be absolute, complete darkness. And that goes for the moon, too. You see, moonlight is just sunlight reflecting on the moon. So even if the sun burned out at night, you'd still see the moon suddenly disappear into darkness. We rely on the sun not just for its light, but its warmth, too. So if the sun burned out, things wouldn't just get dark.
Yes, so quite scary what would happen if there was no sun. The life on Earth doesn't only need the sun, it also needs water. So water is not made in nature, cycled through the water cycle. The sun's heat energy drives the water, so it relies on the sun. From the surface of the Earth into the air and back to the surface of Earth over and over again. This continued movement of water is only possible because of heat energy from the sun. Without the sun's heat energy, water could not evaporate and all on Earth would freeze. In the good old days, grade 4 and 5 maybe. Okay, the process of evaporation, condensation, precipitation, and collection. Fossil fuels, as you know, are examples of non-renewable energy sources. Think about the relationship between the Earth and the sun and how solar energy is stored on Earth. We have learned that plants store the sun's energy and we are able to use that energy later on. But what happens to the stored energy when plants die? To answer this question, we need to go back in time, millions of years back in time. So we ask ourselves the question, what conditions are needed for fossil fuels to form? They need a saturated environment, in other words, lots of water, anaerobic conditions, lack of oxygen, increased high pressure, increased high temperature. We then have to ask, how were each conditions met at the time when fossil fuels were formed? Swamps created areas of saturation and lack of oxygen, anaerobic conditions. As the plants died and layers upon layers were formed, the pressure on the lower layers increased. And as the layers moved deeper in the earth, they were subjected to increasingly high temperatures. It got hotter the further down in the earth's crust, it gets hotter the further down in the earth's crust that you go. Why are fossil fuels important though, grade 7? Because they form a vital part of the economies and lifestyles of all people on earth. They have stored energy which we now use to drive many machines, vehicles, and processes in our lives. But why can't we just keep making fossil fuels today? Because, fossil fuels need millions of years to form. So let's take a look at how coal was formed. So before the dinosaurs, many giant plants died in the swamps about 300 million years ago. Over millions of years, the plants were buried under water and dirt, and then heat and pressure turned the dead plants into coal. A little bit of a recap also from grade 6. Then, what is the difference for petroleum and natural gas formation? So, for petroleum gas, tiny marine plants died and were buried on the ocean floor. Over time, the marine plants and animals were covered by layers of silt and sand. For years, the remains were buried deeper and deeper. The enormous heat and pressure turned remains into oil and natural gas. Today, we drill down through layers of sand, silt, and rock to reach the rock formations that contain oil and natural gas deposits over there. Okay. So, fossil fuels store energy from the sun. The plants that lived millions of years ago absorbed the energy from the sun for photosynthesis. This energy was passed along the chain to animals. When the plants and animals die, the remains are eventually changed into coal, oil, and the energy is stored in these fuels. When humans burn these fossil fuels, they are using energy that originally came from the sun. So, do you see how it all goes back? Marine plants and animals died, fossils formed underground, we got crude oil from that gave us petrol and diesel, and now we're able to drive the cars. So the energy from the sun, or the solar energy, was captured through the photosynthesis by the sea plants. The marine animals obtained energy by eating the plants. Millions of years ago, the sea animals and plants died in the oceans and were deposited on the ocean floor. They were covered with sand and silt and formed layers and layers of dead matter. And over time, through the working of temperature and pressure, the remains were changed into crude oil and natural gas. Crude oil was extracted from the ground by mining and refined to make petrol, which is then used to fuel cars. And can you remember the process? We learnt about it in separating mixtures. Yes, distillation. So what energy takes place within that system that happened? The sun's radiant energy is transferred to chemical potential energy in the marine organisms and then stored within the oil. The potential energy in the oil or petrol is transferred to kinetic energy when the car moves. Why is petrol so important in our lives? We use it for transport, for example, to transport food from farms to cities, to visit friends and family, and we use it to work machinery. It makes our life pretty simple and pretty easy. So if I wanted you now in class to give me an explanation to show the transfer of energy from the sun to a fire made from burning anthracite, which is a type of coal, how would you go about giving me this example? And show me how this energy can be used in human activity. Think about it for a while. What would you write down? How would your paragraph look? Sun is a source of solar energy. Plants capture energy through photosynthesis. Plants formed coal, which stored their energy from the sun. When the coal is burned, the energy which was stored millions of years ago is released. This energy can be used for human activities, for example, cooking. In this way, the sun's energy was transferred through plants and coal to be released from the coal by burning. So, I hope you're getting to understand the importance of the sun for life on Earth. But what happens, grade 7s, if fossil fuels run out? Let's take a look.
We've all heard that fossil fuels won't last forever, but why? And if they are set to run out, how much is left and when will that happen? To dig to the bottom of this one, we first need a quick refresher on how fossil fuels are created. And sadly, no, they're not mostly dead dinosaurs. You see, the vast majority of our fossil fuels come from the remains of plants and animals that lived around 300 to 400 million years ago. And we don't see the first dinosaurs until around about 230 million years ago. So, when these plants and animals died, that very, very long time ago, they were covered in layers of earth or silt. And because of the combined actions of three things: one, the compression from the weight of all that stuff; two, the microorganisms in there decomposing the content; and three, the heat underground, that transformed them into potential fuels. Coal is the remnant of ancient plants, whilst oil and natural gas mostly come from marine creatures, with natural gas being made in deeper, hotter regions where the oil gets a little bit more cooked. Now, we dig or drill this stuff out of the ground, and because it has been accumulating for a long time, initially there was a lot. But because it takes so long to make, we're using it much, much faster than it can possibly be replaced. This means that there is effectively a fixed amount of fuel on Earth, and we're using it up. So, yes, fossil fuels are going to run out, but what is left, and when will that happen? Well, we can fairly easily tally up what's known as our proven resources, the supplies that we know the locations of and we think we have a good chance of getting to. In their statistical review of world energy, BP estimated that the world had just over 1,700 billion proven barrels of oil in 2014. That's enough to meet 52.5 years of global production. They also estimated just over 187 trillion cubic meters of natural gas. That's enough for 54 years. Then 891,531 million tons of coal, enough for a whopping 110 years of global production. But there's also the stuff that we know about, can't reach, but think we might be able to get to someday. Hard figures on that are, understandably, tougher to come by. But oil and gas consulting firm Rystad Energy estimates total probable global oil reserves at 2,092 billion barrels, which is enough for about 70 years if our use doesn't go up. The total fuel resource, the amount of fossil fuels that could be out there that we know nothing about, could of course be even higher. But around 4 years ago, an idea came out that there actually is plenty of oil left, just that we haven't got around to getting it out of the ground yet. This means the numbers for the potential oil out there could in fact be way higher. We've already seen humanity use new technologies to access and use fuels that we couldn't get to before. Things like new techniques to extract oil where it's all mixed up in fine-grained sedimentary rocks like shale, or using high-pressure fracking to extract more oil and gas from the ground. One thing stopping us using these new technologies to extract fuels is that the rising energy costs of extracting it could be just as damaging as the oil running out. Despite the cost of oil, the amount being extracted has actually remained constant, about 75 million barrels per day since 2005. And this means a plateau has been reached, where supply cannot match demand. It's also worth pointing out that fracking is far from ideal. It's been claimed that it has been linked to earthquakes and toxic tap water. We've already seen how the economics of getting to the fuel can outweigh humanity's demand for it. In 2016, around 460,000 barrels a day of high-cost production like fracking was shut down in the US due to the cost. But that just means surely it's there for later, when the economics are right? Well, maybe we need to leave it there. The planet is warming due to the burning of those fossil fuels. Burning fossil fuels releases carbon dioxide into the atmosphere, traps heat, and it causes a greenhouse effect. It's been estimated that we cannot burn more than about a third of those proven resources if we have any hope at all of meeting plans to keep the temperature rise at 2 degrees centigrade or less. Although it may feel that we don't seem to be in a particular hurry to look for alternatives, energy transitions have always taken a long time. It took over 50 years for coal to replace wood as the world's leading source of energy, and another 50 years for oil to overtake coal. So, here's a promising thought. In the end, with so many options for renewable sources of sustainable power being developed, we might actually never have to answer this question of what happens when the oil is finally all gone. Right, this is one where we really want to hear your opinions about this whole subject. Put your thoughts down in the comments below. Subscribe to the channel if you haven't already, and then you'll...
So, grade 7s, just to end off today's lesson on the impact of the sun on our Earth and the relationship that our Earth has with sun, here's my little bit of humor for the day. Over here, 2 animals, you can guess which one is which, and he's saying, I need the sun's energy to warm my blood and give me energy. You could almost say I'm solar powered. And then the energy bunny from Duracell, I just needed to get away for a while and recharge my batteries. So, grade 7s, I hope you have had a good lesson and that the lesson was a good consolidation and recap for you of everything you've learned so far from grade 6, accumulating into everything you needed to know for grade 7. Thanks for watching, grade 7s, and I will see you again soon. Don't forget to download the homework sheet. Take care.